Hey guys, my name is Kay Mishra. I'm the Micromouse Robotics lead, currently the only lead. And today we're going to be going over some basic information that you should know about C++ and the simulator itself. This is going to be a short presentation, it's not going to be too long. Mainly I'm just going to be demoing how the simulator works today. And I'm going to be going over the different parts of the code I've written. Okay, so as you can see on your right, there's like a chart thing, which says like integer, character, boolean, floating point, double, well, etc., etc. And there's like derived and user defined. Okay, so of these various data types, we will primarily be utilizing integers and a smaller space taking up version of integers called shorts. We will be using characters, booleans, doubles, and pointers. And as for data structures, we will be using arrays and vector objects. If you guys have heard of array lists, it's essentially like, vectors are essentially like the array list objects from Java, in which you can like modify their size. I'll cover that more in the later slides. We will be utilizing structs, which are basically custom variable definitions, which like can have multiple different elements within them, and we'll be utilizing stacks. So about vector objects, like I said, they're very similar to the list object from Java. And the reasons why you should use vector over like a normal static array, such as let's say an integer array that's like, I don't know, any given length and contains integers from like 0 to whatever. Right. Vectors, unlike arrays in C++, they can be returned as the function, as the return value of a function. So where you see here, it says vector int, and that's like the return type of this neighbor check function. Vectors are also resizable, so unlike arrays, which after you've declared their size, when you first declare them in your code, you can change the size of vectors. You can't change the size of static arrays. Vectors can also be assigned and copied directly. So let's say I have a vector object that's already declared, right? Normally with arrays in C and C++, you can't just set them a static array. You can't just set it equal to another static array. That's going to give you an error. Vectors, however, you can set other vectors to other vectors, and you can even copy them. Pointers. Okay, pointers are unique. Well, not necessarily unique, but you use them a lot in C and C++. So what pointers are they are variables which point to the address, or otherwise known as the memory ID, of another variable. And in order for your system to access that data value, it goes to the memory ID of where you placed that variable, and then retrieves the data value here. So I have a bit of an example here in the code. Let's say you declare an int called pointer, or an integer pointer called ptr, and you first set it to null, okay? So it's not pointing to anything right now, it's null. And let's say you declare another variable called int var, right? So you now have an integer variable called var, and its data value is 3. What you want to do is, if you want to be able to access var's value by using ptr in some way, you have to set ptr equal to ampersand var. And what ampersand does is that if you put ampersand before a variable, it will collect its address. Right? It'll take in its address value and then set it equal to whatever you're trying to set it equal to. And then here in the code we have what is your equivalent of a print statement. I know there's different variants on this, but this is the implementation we're going to be using in our code. CERR.
Sorry, why CERR and not C out?
Oh, see, okay. So I think it's mainly because the API of our simulator is occupying C out, so it doesn't want to be like confused by.
Gotcha.
Yeah, it doesn't want to be confused by whatever you're trying to input in. So that's why you have to use another console. So the differences in output if you include the asterisk before PTR and if you don't include the asterisk before PTR. So how you dereference these pointer variables, or like, let's say you set the pointer variable equal to the address of another variable, right? And if you want to access that certain variable's like data value, so if you want to access var's data value of 3, you have to first dereference PTR. And how you dereference PTR later on in your code, you have to add an asterisk before its name. So here we're first printing just PTR, and then we're printing PTR dereferenced. So if you just print PTR, you're going to get a random value that, like OX123. Right? You normally don't want to use these. You want to get the data value, so you need to make sure that you dereference the pointer. Some cases you actually want the address location, but if you're just trying to get the data value, remember to dereference your pointer first. And then what code will do, or what your system will do, is that it will go to the address location that PTR has listed, and then it'll pick up the data value from there and print that out. Okay, structs. Structs are very useful. I love structs. Okay, again, this is another one of those topics that you learn more about in CS211. So structs are data structures which can group different variables under one identifier. So as you can see, I have two different structures that I'm using in my code. One struct for coordinates, which stores the value of x and y, and then another struct for cell, which stores some pointers here for the different walls of the said cell, the cell's coordinates in the maze, and the cell's current flood value. So these structs can be declared like any variable, and can have their elements accessed via this fashion. So let's say you have a struct that goes by struct A, right? So you want to create a new struct variable. So you say struct A foo, just like how you would declare an integer version, int foo, right? And then if you want to access the individual elements from your newly created structure object, you type the structure object's name, and then you type the element name from the struct. So let's say I have a cell called foo, right? And if I want to access the north wall from the cell, right, I have to do foo.north wall. Or if I want to access foo's coordinates, I have to do foo.coords. Okay, another important data structure that we'll be using within the code is stacks. Now, stacks are actually rather nice data structure. They're very convenient. They work like laundry baskets. Okay, so in a laundry basket, let's say you throw some clothes in, right? The clothes you put in the first go to the bottom of the laundry basket, right? And then the clothes you put later on stack on top of those other clothes. And those clothes are closer to the top, right? So the main stack methods we will be using, oh, by the way, is we won't be making our own stack data structure. That's too annoying. We're just going to be using the stack library from the C standard library. Okay, so push is one of the main methods we're going to be using. It just pushes an element onto the stack. So let's say you have an empty stack here, you push in 1. Right? Now 1's at the bottom of the stack, but it's also the top value of the stack because there's no other values there. And you can push in 2, 2 becomes the top value. And you can push in 3, 3 becomes the top value. And top, okay, so we're going to be using top to check the top value of the stack. So whatever values like you most recently put in, you'll be able to access that. We'll be using pop, which pops the top element out of the stack. And we'll be using empty, which checks whether or not the stack is empty. So if you called the empty method on this stack, it would return true. And if you called an empty method on this stack, for instance, it would return false because it's not empty. Okay, so simulator basics. This is like 2 slides. There isn't much to cover. The commands are very self-explanatory. Okay, so the main commands from the simulator we'll be going over is wall front, wall right, wall left, move forward, turn right, and turn left. Okay, and these commands are all provided by the API files that you will get, like this one right here, api.cpp and api.h, the main C++ file and its header file. These all do pretty much exactly as you'd expect them to. Wall front, it checks like for wall to the front of your mouse, wall right checks to the wall to the right of the mouse, wall left checks to the wall, for wall left to the left of your mouse. Keep in mind these are only within one cell distance, so it can't detect any walls that are like far away. Move forward, you're probably only going to be using move forward 1. That's the default distance set by this command. I mean, if you really want to, I guess you can set it to be more than 1, but I would not recommend it. Just keep it at its default. You can just one step at a time. Turn right. There are no 45 degrees turns, by the way. That's why I specifically mentioned you turn right by 90 degrees and turn left by 90 degrees. In a normal competition, if you want, after you've solved the maze, or if you just want to not bother with 90-degree turns for some reason, you can have your bot turn 45 degrees in the maze. There are actually some instances where that's useful. Let's say this lane right here. Right? Instead of turning right and then turning left and turning right, you can just turn 45 degrees and then go straight. And then, yeah, it's helpful in a lot of situations. Not too many people get to use it though, because it is a pain to implement in real life. Let me tell you that much, because you have to watch out. You have to be very precise if you want to make those kinds of turns, and you want to make sure you don't run into any walls while you're running through a diagonal path. And some extra commands that we're going to be using. They're available to us, and most of these commands I mentioned will be of some use to you. So for instance, set wall. Again, you don't necessarily need to call these, but they're very useful when you're trying to view what's going on in your program on the maze. So set wall, it sets a wall in the input direction respective to the cell at the input coordinates, as you can see here. Right, so let's say if I wanted to set a wall to the east of cell 00, right, I would call set wall 00W, and that would set a wall right here. These walls are already present when you first load the simulator and select your maze. But what this function does is that it makes them more apparent, and we're going to be using them in our code to show that, okay, our algorithm recognizes that there is a wall, and it has now stored the fact that that wall is there. Set color. It sets the color of a cell at the input coordinates. So as you can see here, this cell is colored differently from all the others. That can be useful. I didn't really use it in my code, but if you want to, you can use it in your code. I know in one of the examples on the GitHub page, they changed the colors of the cells that indicated the shortest distance to the center, and they kept updating them as their mouse went along the maze. So if you want to use that, it could be helpful. Or if your mouse detects its speed run, it could set all the cells it has traversed over a certain color to show that, okay, this is the fastest path. I'm taking my fastest run now. And set text. Set text is, what it does is it prints any text you give it onto the input coordinates. So here, if you want to set text of 00, of cell 00 to 0, it'll just show 0 here, as it shows 0 on the center of the maze here. And this is really useful for visualizing flood fill, because with flood fill, what it's going to be doing is it's going to be constantly updating the values of the cell your mouse is on and the cells around your mouse when it needs to update the flood fill values. There are some other commands here in the API. These two specifically, I implemented whenever I wanted to stop the program. This basically detects if you hit the reset button, and then this just calls for a reset. And this clear text I didn't really use. I don't see any point using clear text. And yeah, these three I mentioned here are can be very useful if you want to use them. And more descriptions on these commands, the main commands and the extra commands, they're available on the simulator's GitHub. I think I have it pinned to the Discord chat, so if you want, you can go visit it. And yeah, that's it. That's it for simulator basics and C++ basics. I guess I can show you guys how this algorithm works. And this is the main thing I wanted to discuss today. Well, not the main thing, but one of the main things. So here, let's go to example maze 1. Right? The simulator, we have our run output, our build output, etc., etc. We don't really use this tab. We mainly use the run output tab, which is basically, it also tells us if our bot is crashed, if it crashes into a wall. There can be issues sometimes if you like cancel. So try not to do what I just did and cancel the program. I don't know why I hit cancel. I should have hit reset. Wait, so let's see the bot run in the maze. Let's see if this algorithm actually works, if flood fill actually does what it's supposed to do. I would hope so, because I've tested this like a million times throughout the weekend. If it doesn't, that'd be really awkward. So it's outputting a bunch of different things, and it's changing a bunch of different texts on the simulator, right? It's saying where it's moving to. And it also has whatever this means, you know, return to starting point, flipping cell values. Like, what? Retracing the maze. Yeah, and then it says at the end, run complete, speed run achieved. And then here you have the stats tab, which tells you how many squares you move forward, how many squares you move forward on your current run from the starting point to the center. But let's run the simulator one more time to see how the stats tab updates. So yeah, as our mouse is moving, it keeps track of the total number of turns we've taken and total number of distance we have covered. Right now, we have a score of 2,000. Okay, now, it updated. And there's actually an equation for this score, which is on Princeton's page. I will also go over that. And I will present the problem of why we don't necessarily need to go the shortest path each time. Here, it's fine. Here, go for the shortest path. It's going to boost your score by a lot, right? But for some of the other mazes we have here, it might not necessarily do that. So for maze 1, right, score is 2,000. Not what you want in the competition. You want to actually reach the center first. Okay, and wait, okay, now it reached the center. Okay, so our current score after it reached the center, you know, our best run is 140, and best number of turns we have is 56. Given like the optimal path for this maze, this is not the best run, obviously. So you're probably going to have to go back to the center and make another run, right? And your current score is 215. All right, so what our mouse is doing, it's running flood fill right now. It's trying to determine, okay, what's the shortest path I can take? Okay, this should be the shortest path. And your score dropped once you got a better best run distance and best turn value. Right? Your score dropped from like 216 to 155. That's pretty good. But maybe you don't necessarily always want that, you know? Right, for this maze, okay, our best run distance is 38. We got to the center pretty quickly, right? I don't know if you caught the score at the beginning. I can run it again in case you didn't see. Right, so our bot again is searching for the shortest distance to the center. Okay, so we got best effective run distance of 26, best number of turns at 16. You know, this is probably the shortest path you can take to the center. But here's the problem. What was the score from our first run? The score from our first one was 66.3. I can't pause it at like the right time. Maybe I can slow it down. Hang on. Okay, so yeah, our current score is 66.4 and our best run is 38. But why? Like, we got a shorter run, you know, later on. We got a run of 26. Let's say that's a pretty effective decrease. And, you know, our number of turns was decreased as well. How come our score is like lower here? That, my friends, is one of the nuances of the competition. So if you go to the official rules page, They have a little algorithm here for your final score, right? So your final score is going to be the number of best run turns you have at the moment, right? So the moment that's 38 and 22. And you're going to add that to 0.1 times the total number of turns plus the total effective distance you've covered. What this essentially means is that, let's say you had I don't know, you had a hard time finding the center of the maze, right? And then you decide to go for another run to potentially increase your score, right? It was 4, okay. So, yeah. In 4, you cover a lot of the maze. Like, you go through, you basically take a round trip. You don't cover all of it, but you do cover a lot of it still. And see when it reaches the center. Okay, so your current score is 388, and you've run over 216 squares, and made 132 turns. That is a lot, you know. And what Armrest is going to try to do is, okay, there's definitely a shorter path, right? So it's going to take that. And yeah, because your best run distance is so much lower than what your current run distance was previously, your score gets cut down by a lot. But if we look at Maze 2, right, where you reach the center rather quickly, right, is there really a need to go for another run if your best run distance is not even that much more than your current run distance? Because that can and will increase your score if you decide to search for the shortest route anyway. So yeah, I was thinking of different ways as to how we could approach that problem. Like, when should we tell our bot to take the shortest path, or just keep its current run and stay in the center and just end the program? And that'll keep our final score as it was. So when we made the first run, right, we could just tell our bot to just stay there and keep the score of whatever, right? But the question is, how do we determine when should we take the shortest distance versus when should we take the most optimal run? Right.
Wasn't the shortest distance just a number in the start?
What do you mean?
Like in 0, like 26 would be the shortest distance?
Right, so that is, Floodfield does give you some clues about how your distance would fare. What it assumes to be the farthest path, or like the shortest path from the center to the starting point, right?
Mm-hmm.
But you don't know for sure. It might take multiple searches of Floodfill to get the shortest path to the center. Right. Some mazes you can just you can run Floodfill once. Right. It can go from the starting point to the center and then back, and then it'll have the shortest path. For other mazes, you'll need to do that same trip 2 times or even 3 times. Right, and that effectively adds up to your total distance, your total score, right? And that's going to increase your final score value. So what our objective is to see when should we try to go for a shorter run and when should we just keep our current run. Right? This is more of a probability question. Like how many squares have we gone so far, and how many turns have we had to make over that distance? Maybe you could do something with those values, and then try to predict. Your algorithm can try to predict, like, okay, let's say while it's at the center, like let's say, okay, so when you first reach the center, right, the value at the center, this value, what it indicates is it's estimating how many moves you're going to have to make in order to reach the starting point, right? So it's 22 right now. So it's saying, okay, you might only need 22 moves to get back to the starting point. But that's only because it doesn't know about the walls here and assumes there's like no walls here. Right? And if you decide to just go with that and say, okay, let's see, based on the number of turns I've taken and the distance I've covered, like you can do a calculation real quick, ratio of turns to distance covered. So 22 over 38, it's going to give you 0.57 something. Multiply that by the estimated distance to the starting point, 22, right? You're going to get a value of about 12.7, and you can round that up to 13. So now here's the thing. You're going to be covering, you're supposedly going to be covering 22 moves and 13 turns twice, because you have to go back to the starting point and then you have to go back to the center in order for it to be considered in your score. Right, so you can do 22 plus 13 times 2, because it's going to be a round trip. Right, you get a value of 70, and add that to your current run distance, 38, plus 22, you get 130. Right, and multiply that by 0.1, you get 13. And then add that to your estimated best run and best turn distance, 22 and 13. Like, okay, you estimate that your score will decrease to 48 in comparison to 66.6, but that doesn't happen, right? Your score actually increases by the end. You end up with a score of 87. We just run this through. It ends up at 87.3. Why? The reason why is because we had to make multiple searches, because we hadn't covered the entire maze by that point yet. And that eventually led to a higher score than we needed to have, compared to if we just stayed at the center once we found it. Right, so there are some things that we will have to consider, right, to let our algorithm know, like, okay, maybe it's best to just stay in the center instead of go for another run. Because you can make more than just one round trip. You can make multiple round trips. All right, so does anyone have any thoughts about the final score layout, or maybe how we can approach this, or any questions about how we should approach this? I think I mentioned this. I don't know if I mentioned the chat all too well. Okay. Seems I didn't. Okay. So in the chat, I said, I think I said to one person that he was concerned about, like, okay, well, I'm not too familiar with C++, right? And I don't have that advanced knowledge about this algorithm or whatever. Right? I'm like, okay, that's fine. If you're having troubles implementing the code, you can just tell me your idea and I'll try to help you implement it as best as I can. All right, so let me know if you guys have any ideas as to how to approach this problem. I have a couple of my own ideas, but yeah, I'll wait till a later date to share those. So how do you even use the simulator? Okay, so obviously you can't just download the repository and start using it right away. I mean, you can, but you won't be able to code as effectively. You have to install Qt Creator. Where is the instructions for this? Here, you can download, it says you can download precompiled binaries from the releases page. We don't want to do this because we want to get the most recent version. We're building from the source. So what does that mean? That means for Windows, you have to go to this website called Qt. Qt is basically a platform that is very effective in helping you design applications based on C and C++. As you can see here, this looks like a commercial product. There is a community product. Yeah, downloads for open source users. So you want to go to here. This is earlier. Where'd it go? Okay, here it is. So Yeah. You can download the online installer. Right? You can install Qt onto your computer. I already have the installer. So Qt. There we go. So this is a Qt application right here. Next, you have to make it. Oh, right. This is the annoying part about commercial products. Even for open source, they're making you make an account for them. Just make an account. You don't have to like necessarily receive any notifications or whatever marketing emails they're trying to send you. Just make an account so you can use Qt. I already have one made. Okay. When you get to this page, the Qt open source usage obligations, just click this, because you're not doing this for any company. I guess do you have to? Okay. Please enter your company. Okay, now I can just go next. Okay, so setup. And if you miss any of this, I will have this video uploaded to YouTube, so don't worry about that. Okay. Again, I'm not actually installing this. I'm just going over what the installation procedure is like. I don't know what this is about. You can send them pseudo-anonymous statistics. I don't really care. You could select which folder Qt is installed to. Normally, they just install it directly to your C drive or whatever drive you have. They don't go into the program files folder or anything. They just make their own folder directly on the drive. And yeah, you want to make sure this option is checked because there are some files specific to Qt Creator. I don't know if any of you are familiar with CLion. CLion is also a IDE for C++ files that you can use. The reason we're not using a CLion instead of Qt is because, as I said, there are some specific project files specific to Qt that the simulator uses. So that's why we need to install Qt. Okay. It already exists. Okay, I'm just gonna say install in program files then. Are you kidding me? Qt, there we go. Installation path must contain. Windows path. Okay, fine. You won't have this issue because it's gonna install it directly. I don't know why is it doing this to me. Okay, fine. I'm just gonna set you. Yeah, sure, why not? I'll select desktop for right now. Okay. No. Create a new directory, please. Okay. So you're gonna get to this page, and it's gonna list out some options. Go under Developer and Designer Tools, and you want to check off that you have MinGW, the latest one, installed for Developer and Designer Tools. It's fine if you want to use 32-bit instead. I personally use 64-bit because my machine is capable of that. Most machines are generally capable of 64-bit programs, running 64-bit programs, so I don't think that will be too much of an issue. So just install the latest version of MinGW, select that, and then what you want to do is you want to go to the latest Qt version, Qt 5.15.1, and do the same thing here. And that should be good. And you hit next, right? I have read and agreed to the blah, 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 whatever. Right, it's gonna start menu shortcuts, and it's gonna be ready to install. I'm not gonna install because I already have it installed. Right, you're gonna open Qt for the first time. It's gonna look like this. bunch of different stuff here. What you want to do is you want to first go to File. I think your screen will probably look a bit different, so I'm not installing it for the first time, but basically one of the main things you want to do is you want to go to File, right? You want to go to wherever you install or downloaded your simulator, wherever you have your simulator folder located. So I have it located here, an MMS master. And then what you want to do is you want to go into the source folder here, and you want to click on the MMS Qt project file. It's very clearly labeled. It's mms.pro. And then basically open that file, it'll open the project. I already have it open. You just close that. So go here. Open project files. And what that will do is it will open all the project files related with this. So, you know, these are the simulators files. You won't have to go over this, right? But you will have to build this the first time you download the repository from GitHub. Right, how you do that, you just go here, click code, download zip, right, and then copy this to wherever you want. Make sure you have an unzipping tool like WinRAR or 7-zip. I use WinRAR because it doesn't matter. Some people say 7-zip is better, but I don't really care. And then just unzip it. Right, you're gonna end up with a folder that looks like this. You want to navigate to the source folder, and then you want to open the Qt project file, right? But you don't have necessarily all you need just yet. What you want to do is after you build your project file, it's gonna then put in some folders here, bin, build, and build MMS, Qt, whatever. You want to go to bin, and you will see this executable here, MMS, right? I created a shortcut for this on my desktop that basically launches the simulator from there. And then that is what is going to open up your simulator. Okay, well, if you have any concerns, you can always reach me after the meeting or DM me on Discord or just at me, I guess. I'm usually around a lot of the time. Sometimes I might not answer immediately, so don't worry. I will read your message and I will respond to you, if not immediately. You know, and yeah, if you have any issues installing Qt or getting the simulator to run, contact me. I'll try to help you however I can. If you have troubles with the virtual machine, do keep in mind you don't necessarily need to install the virtual machine. That was just because, you know, I wanted to, why I said in the earlier video that you should have the simulator installed is just that I didn't want to run into like any issues when like transferring, you know, different code to different executables. I realize now that's not that much of an issue. You can just transfer the code you've written to GitHub, and then I could, you know, pull from that GitHub through the virtual machine. I'm sorry. I'll take care of the virtual machine part, is essentially what I'm trying to say. So don't worry about the virtual machine. Just get Qt and the simulator on your computer, and you're good. You're golden.